Okay, folks, so we continue our journey into integrals. I want to remind you of my daughter's T-ball team that was sponsored by Integrated Information Solutions. And yeah, as you saw earlier, I kept her shirt. And wow, I don't know how to even introduce this, but yes, I kept her shirt. And so, again, shout out to Integrated Information Solutions. And call me if you would like to sponsor me here, Integrated Information Solutions. Kind of hard to breathe here. But anyway, so we're going to do example 2 now. And, I don't know if I'm going to be able to breathe here. Now look, we talked about when you find derivatives, you can apply derivatives to terms. Wow, I'm scared to reach up very high here. This is bad. All right, this is quite a flattering look here. This is my daughter's shirt, I want to remind you. So anyway, the idea would be that just like derivatives, there is linearity. And if you have terms, you can integrate each individual term. Integration, just like differentiation, can be performed term by term. And so if you have an integrand that's comprised of terms, you just got to do each term. So what's the integral of 1 with respect to x? What would you take the derivative of to get 1 with respect to x? X, what's the derivative of x? 1. Minus, all right, and then look, on each of these others, wouldn't we employ the power rule, all right? And so on this one, and by the way, when you have a coefficient like a 5, you carry it down, and then when you apply the power rule to that, that'd be 4th over 4, n plus 1 over n plus 1. Coefficients carry along just like they do on derivatives, all right? And then, same thing, 4, and then x to the 7th over 7, and then, now I'm supposed to count wrong if you forget to do this, plus a constant, all right? So that would be the antiderivative of that particular one, and that's it, all right? So, these are actually just kind of one step as long as you understand them, just like anything. Now, how about this, in order to consolidate some steps here? Moving on to this next example here. I hope when you see 5 over x to the 6th power, you would say, I'm going to call that 5x to the negative 6th. We've been doing this for a while here, whereby we do the algebra rewrite from the question to the board here. So that would be 5x to the negative 6th. 4x to the 2/3? Yep, 2/3. All right, 4x to the 2/3, and then the minus 2. And this is all with respect to x, all right? So there we go with that. And now we basically have two ideas. We have terms, and so linearity, and then to each of those terms we can apply the power rule. So n plus 1, that would be 5x to the negative 5, negative 6 plus 1, and then whatever that power became, that's what you divide by. And I will tell you, you could always check this by taking the derivative. Here, the 5's would cancel. I'm not going to make a big deal about the simplification on this first assignment. Just demonstrate a knowledge of how the rule works. All right, plus coefficient carries along 4. All right, x n plus 1. So you look at that and you go, well, what's 2/3 plus 1? Well, 1 is 3/3, so 2/3 plus 3/3 is 5/3. And then we could put that over 5/3, but I want you to get in the habit, that's n plus 1 over n plus 1, of changing that division by 5/3 into multiplication by 3/5. So this is 4 times 3/5 x to the 5/3. Should we multiply the 4 over 1 with, yes, that'd be 12 over 5, all that kind of stuff. Not a big deal. You can leave them unsimplified on this first example, on this first assignment. And then the derivative, the antiderivative, the integral of 2 with respect to x would be 2x. And then plus c. I'm supposed to count the whole thing wrong if you forget to do that. I don't want to have to do that. So once again, please do not leave me with that dilemma of forgetting the plus the constant. Okay? So, Couple more here. Hopefully I can keep breathing before my face turns the same color as this shirt. Whew. All right. Whew. All right. Next one. Isn't the fourth root of x cubed going to change into x to the 3/4 power? Okay. Plus, and then look, I'm going to do some of the algebra from the screen to the board over here, but I hope you would agree that that would be x to the 1/2, and then you pull it upstairs. So doing those two things, wouldn't we have a negative power because we brought it upstairs, and wouldn't it be the fractional exponent a half, negative a half, radical, fractional, brought it upstairs, negative. All right, and then basically we have terms, and here for quite a while, we're going to have you integrate expressions comprised entirely of terms, which is the better case scenario. And so really there's two principles to be applied now. There would be linearity, terms, and then to each of those terms, we would apply the power rule, n plus 1 over n plus 1. So, x to the 3/4 plus 1. Well, 1 is 4/4, so 3/4 plus 4/4 would be 7/4. And then instead of putting that over 7/4, isn't that times 4/7? All right, let's invert multiply in our head. We can do it. Plus 5, coefficient carries down just like when you do a derivative. X to the, what's negative 1/2 plus 1? Positive 1/2. And then instead of putting that over a half, isn't that times 2? Okay, and then plus a constant. Waitress, there you go. I would like to think that that would actually be enough of those examples, plus I'm about to lose the ability to breathe here with this shirt on, so there is another example on that slide, but I think we've covered basically everything we need to talk about here. And so I'm going to call it good, and again, why don't we end that series of examples with our favorite cheer. So here we go. Let's go integrals.